Down in front. Down in front. Down in front.
So I think
I'm all on board. I haven't met her.
Kind of romantic. With the lights, looking at the candle.
All right, hi everybody. Thanks very much for coming. Last week of the semester, it's a nice attendance. Just want to mention really quickly, obviously this is the last briefing of the semester, and Michael will mention this at the end, but Michael will be running things starting next semester as we are making this an official part of a campus weather service duty. It's just kind of been, Dan Tomaso restarted this a couple of years ago and then kind of handed it off to me, and we just want to make sure that this tradition continues in the years to come. And obviously Campus Weather Service live streams it too, so it's kind of a natural thing to do. So starting next semester, you'll be getting emails and notifications from Michael. So thanks everybody for coming, and Rich is here for our final discussion of the semester, which is tradition. So thank you, Rich.
Thank you. Thank all of you. Thanks for showing up. Fine, enjoying it. It's like, must be pushing 50 out there. I wish I was pushing 50. Huh? I think I'm pushing 60. But so we're just gonna it's been a really warm semester. We had a really nice November, and it was supposed to be really warm this past week, but it wasn't. We've had a lot of really rain-free days, but we've had a couple of good rain events, and we'll look at the trend as we move further into the month of December. I mean, everyone's been excited about El Nino and the prospects for the winter. We've heard a lot of seasonal forecast potential based on El Nino and the NAL. We'll take a look at what's the state of El Nino, and we'll look at these new CFS plumes that are being generated. These are 2-meter temperatures in some key fields, which I think are kind of interesting and cool, and actually warm for here, but that's okay. It's another story. And then we'll take a brief look at our recent fog and freezing fog event. And I think the screaming message was we got crushed. If you used any of the larger scale models, we got absolutely crushed on our high temperatures. Even the NSET version of the HER got completely crushed on daily high temperatures. Our national blended models, that's supposed to be our new forecast tool, I think it was forecasting like between 47 and 50 degrees almost every day. And we, at least at the office of my house, we never got above 40 any of those days. I had a high on Monday. I think it was Monday of like Tuesday, 34 degrees. So, and it was, we were in the fog. So what happened? We were mystified, but. Anyway, the big mist is over. So anyway, and then we'll talk about the finals weather, and the big question is, as we approach the 20th of December, which is our record latest measurable snow here, will we crush it? And what's it?
26.
The 26th.
Yeah, Twitter was premature.
Okay. So the XMASIS has an error in our office.
He's missing something.
He's missing something. 1923. That's what we came up with originally, Charles Russ and I.
Yeah.
Depends how you do it. John came up with a different number using the range. We came up with December 26th. Yeah. Interesting. So anyway, so the big question, if Bing sings, we don't break the record, right?
That's right.
So I won't sing, that is. So anyway, so this is just this is 60 GEFS plume diagram showing we're supposed to come close to 50, but I think this plume's getting crushed. I think the curve at my house was at 48. It was at 48 degrees at about noon, and the curve was like going way up. It's nice and sunny out. It says maybe 55-ish, pushing 50, mid-50s tomorrow, and then in the upper 50s near 60 Saturday and Sunday. And then we trend almost towards normal later in the forecast period. Of course, you can see there's a big spread showing us there is some uncertainty. But I think the amazing thing is not the temperatures after December 15th, but is the A50 chart. And this has been an issue, as our A50 temperatures are just well above zero. And that's just pretty amazing. It looks like our A50 temperatures do actually go below zero, at least after about the 18th. So that kind of gives you a warm feeling, and it's not good for snow. We need our snow to form at 45 degrees around here, clearly. It's even above zero at 700. That shows you how deep our air is. So if we can stay sunny, we have a lot of warm days ahead of us. The models, the GFS here is trending cooler after about the 15th, and the CFS kept forecasting a warm December and January. We'll look a little bit at the CFS. This CFS, I don't know if it's gotten better over time or it's just getting lucky. So this is the CFS forecast, the temperatures from the new GUI that they put together. And this is for Williamsport. They don't have a point in State College. We'll have to clamor about that. But it basically gives it's a lagged ensemble, shows what the black line shows the mean, and then the spread is the blue, and then shows the different runs. The blue's the coldest run, and the red's the warmest run. And you can see it's been all along showing this warm peaking now for about a week and a half, and then it kind of drops off more towards normal. It's 20. I think they need to put a 32 or a C line on this chart. But there's the warmest run of the CFS shows right around Christmas. We get a really warm feeling, and then it cools off again. But there are some hints of some CFS runs that are cold, but overall, it looks like we're trending, towards some normal. It looks like January might be kind of normal, maybe, if you believe this. But if we look at the plan view maps, there's some kind of discrepancy I don't understand. But this is a new interface that's been written, and you can click on the different things. You can see where the things it's going to snow. The 0Z run this morning actually had snow on December 25th, but it's going to change, of course. But it actually shows a lot of QPF. I think the CFS must have a wet bias. But it's a kind of a cool way to get a quick snapshot of what a range of solutions might be. I wouldn't put a lot of faith in this. So anyway, I put the link in here. This is the Nino 3-4 sea surface temperatures showing what they're supposed to peak. I guess right around now, and then they're supposed to drop. But we're still in a pretty strong El Nino, about 3 standard deviation anomaly it peaked at. But we're on our way down. And I guess traditionally, if you read the literature, like after really big El Niños, we tend to go to a nice La Nina. So I guess people who like hurricanes are probably getting excited about next year. If we go into a La Nina, and there's hints in the CFS that might occur. I would say might, but some of the biggest, almost all the really big El Niños have gone into La Ninas. So people who raise your hand if you like tropical weather. So, bananas have an appeal. Right? So. And then there's the sea surface for the three month period. You can see there's the warm water along the equator, really pounded up against the western United States. And this area here, if I point it out with a mouse, maybe not. Yeah, this area here is a nice area where we've had, for some reason, in juxtaposition with a nice strong jet. So it's been a little bit wet in Seattle. They've had a slew of rainstorms up there. So anyway, you can see there's a cold pocket that people are excited about that might affect the NAO, and it yet has done nothing for us, I guess, at least that I'm aware of. But so basically we're saying through at least February we're going to have this nice El Nino, and then this just shows the CFS 2-meter temperature anomalies, and the 2-meter temperature anomalies for the 3-month period. And these are skewed warm, and they're front-loaded warm if you look at the monthlies. But basically it's saying that all of eastern North America is going to be warm. And if you want to have a chilling experience, in ski, go to Sandia Peak in New Mexico, apparently. And that's kind of I don't know if that's a traditional, it's a quasi-reasonable teleconnection for temperatures, I guess, for the El Nino. But this is the precipitation. And if you've been following the CFS initially was dry, like in Vancouver and Washington. And recently, the CFS forecasts have gotten wet, and it's been pretty wet in Oregon and Washington of late. We'll take a brief look at that. And it's forecasting it really to be dry in the Ohio Valley, which, if you look at the series of storms coming out of the Pacific, that looks like an area that's going to be wet, at least initially. So maybe they'll turn dry, and the East Coast will get wet. But that's a kind of a nice teleconnection pattern that we kind of are used to wet in the west and wet and kind of cool in the south and southeast. So we're on the cusp of being wet or dry, like equal chances. And this is the everybody always likes the NAO and the Arctic Oscillation, and this is kind of shows what it's been. It's been highly positive, and there's some suggestion that in some runs it wants to go negative, but for the most part it wants to stay at least weakly positive. So if you're a big fan of the NAO. And you like negative NAOs, this is not your year so far. Interestingly enough, we tried to correlate daily NAOs with snow this year, and we found out that the biggest snows in State College occur with positive NAOs. So, but people say it's the sign and stuff, but you can do the monthly value, whatever. But anyway, for what it's worth, the NAOs probably going to stay mostly positive at least till the end of most of this month, as far as this forecast goes. So anyway, we had this fog experience, and I'm still trying to clarify what it was, but we had this nice stable pattern, weak flow, warmer aloft, kind of traditional, kind of get fog. And how many people thought that 5 days of low clouds and fog was kind of boring, or really just kind of got you depressed? So what's the most? Who here has ever experienced more than 10 days of this? Who has ever experienced more than 15 days of this? I went through this in November of 2003 in Kosovo. We went 15 days and we never really saw the sun. It was horrible. It was depressing. So the bigger the mountains, the more lingering the problem. I figured maybe somebody went to school in Utah or got stuck in Utah and experienced this, but it was what? Fresno?
Yeah, they get this.
Oh, yeah, it was interesting. So this is like the mean pattern. You can see there was a big ridge to our north and west at 500. It was pretty warm over our area north of us at 850. Warm over cold. There was a big anticyclone at the surface in the mean pattern, and actually, it was dry. Not as dry as my sense of humor, but it was pretty good. That's the principal water down there. But it didn't matter. All the action for the fog was in the boundary layer anyway, and these models clearly demonstrated they have no clue what's going on in the boundary layer. So, and we also, prior to the event last week, remember we had about a 2.5 day period where it rained, and this just shows that we had like a general 1 to 1.5, and a few spots had, maybe 1.5 to 2 inches of rain. So the ground this time of year is usually frozen, so we don't think this is a really foggy time of year like this. And it's either frozen with snow on it or it's just frozen. Well, this year the ground's nice and soft, and you can dig in it and put your Christmas light things in the ground nicely and easily if you want to. And we had a lot of rain. And we in the warm season when we have a lot of rain, that's a good setup for fog. Well, we had a nice setup here for fog in December, so something we're not really overly used to, I don't think. So this just shows the evolution of the anticyclones with time. You can see early on Saturday, Sunday, Monday, we were under this big area of high pressure. And the high pressure kind of fell apart when you get to the 7th, but the flow is just really, really weak. Now the 9th got a little bit more of a gradient, but I think we were so decoupled it didn't matter. And sometimes you have to go with the flow. In this case, there was no flow to go with. So anyway, you can see at 850, we started out a little bit on the cool side, nothing remarkable. When it got warmer and warmer aloft, then we had this, nice inversion. And that's why the models were forecasting day after day it was going to be in the upper 40s, sometimes in the 50s in places, but it just never really happened. So, and if we look at 500, you can see we actually a trough had gone by with our rain, and then we got caught in an upper level ridge. And there was actually at the end there was actually a trough that was coming through that brought the little bit of rain last night. Actually cleared it out, and then it radiated just before sunrise, and pop goes the fog. So we did it again. So we'll probably have a little fog again this morning. So tomorrow morning rather. But anyway, so these are the plume diagrams. These are from the 7th, and we were supposed to be in the 40s like Monday, Tuesday, and we never quite got there. Show you the boundary layer physics in these models are really bad. They had no clue what was going on. We had huge errors in the SREF. Here's days in the 50s and temperatures in the 50s here, and it never happened. So this is actually this is the G. This is the SREF on this side. This is the SREF on this side. Just different types of initializations, but they were forecasting really warm temperatures, and they got crushed. So there's sometimes high resolution data really can maybe help you out. And the other thing you notice, we were pretty warm at 850 most of the time too. So in summer we had the nice warm wet ground in a relative sense. I mean, usually when I mess around in my yard this time of year, it's frozen or it's snow covered, and it's not. And even at the low temperatures we had the last couple of days, there's no frost in the ground to speak of, and it's wet. The ground is really, really wet. So stable, all the conditions for radiational fog, and we had a lot of temperature busts. And the only forecast product I saw that had any hope was the HER-X. It had some clues, and it kind of showed the low-level cold air staying in better than the NSEP-HER. The HER runs were a little better, but I wouldn't have hung my hat on them, too much. Even yesterday, the HER-X kept saying it was going to be foggy here till noon, and it kept clearing it out. So our models have a long way to go with the correct data and the correct parameterizations or the correct simulations of what goes on in the boundary layer. The boundary layers are apparently our Achilles heel, and it has to be dealt with, I guess so. So anyway, finally, the final weather. It's a lot of final puns, right? Bada boom, bada bada. How many people have finals next week? Lucky you. So anyway, we have a potential for a nice big warm-up. I don't know, what's the record high on Saturday and Sunday here?
Probably near 70.
Near 70. So it's going to be tough. But there have been people clamoring for breaking record temperatures here, but it's going to be warm. And then we have a cool down toward normal, and then we'll ignore the 6 EG at best. 3 snowstorms. No, that's a funny thing. We were coming here. I was here this morning to go with Kyle to class, and we stopped by Bill's office, and the 6Z GFS had like a series of snowstorms. Like it was like Nirvana. It was like I was like, I'm a snow crow. And I saw the runs, and I said, so what does the Nafes have? And then the Nafes didn't even have it cold enough for snow. 52 forecasts kind of killed the gusto of the one. Sometimes the forecasts of the many are better than the forecasts of the one.
Yeah.
It's a little Star Trek humor there for those who. Yeah. So my ears are not that pointy though. So we'll look at the ensemble. So it always pays to temper yourself with an ensemble, except when the boundary layers at work. Then you got to go. The her is your best shot. So when you're in a hurry, use the her, right? So this is the 500 pattern from the. I have to go. It's alternate F11. Is that right? Why isn't that working? Full screen is function F11. I think this GUI works. This is a new GUI I wrote. I think it works with arrows. Everything. Maybe it doesn't. It doesn't mind. I'll try this again. Let me see. It has to go. For some reason, it has to go. I don't understand. I know just enough to write dangerous software, I've determined. You can read the dates down. This is the GEFS boundary, a bias corrected version. So we'll go back to the beginning, right? So what Rossini said. Everybody got that joke. Or watch The Princess Bride. So, all right. So here we go. You see the big wave come into the Pacific Northwest, and the ridge just builds over us. We peak out at about. I love the way this thing goes back and forth. About almost 2 standing deviations above normal, and the 850 temperatures in our area are above normal. We finally, a little wave is supposed to come by around the 18th and get us to near 0 to 850. Then we just pop up warm again, and in this forecast system, this goes all the way out. There's Christmas Eve. There's Bingland. We're about 0 to 850, and then we finally get about the -4 potentially at 850. So big broad trough, no big anomalies, and it's not very exciting. I'll try that. Is it a controller function 11, or is it the window? Oh, I'm hitting. Use the error. There you go. It's like last night I was putting new software on my computer and it kept saying hit the Windows R, and I'm hitting the function R to run a command, and I don't follow directions. You can ask my wife. So anyway, we'll go to. Let's see if the 12Z came in, by the way. No. So we'll go back to the 0Z. We'll go to the US scale. And we'll look at the surface because there was the potential series of cyclones. So if this is going to pick up these surface cyclones. So it shows we're under weak high pressure, and this is the 925 temperatures below. We're pretty warm. Lows go into the lakes, which doesn't bode well for that dry in the Ohio Valley. And lows just come into the plains and go to the lakes, and we're kind of in never land here. But I think the more interesting thing is the stuff coming into the west coast. So we'll switch to 250 winds, and you can see the strong jet coming into the Pacific Northwest, 120 meters per second. That's pretty strong. And then another jet comes into the Pacific Northwest. So the Pacific Northwest just keeps getting hammered with jets. And we're kind of in a ridge, I guess, and we're pretty quiet. So the storm track looks like, temporarily at least, is still skewed way to our west, which doesn't bode well for Bing Crosby singing any White Christmas songs. Maybe he'll sing Holiday Inn instead. But anyway, that's an old joke. So, this does not look impressive. So if we go to the GEFS, I don't know if we'll try 12Z. It may not have run yet. Oh, it's coming in. So I'm going to show 2 things at this scale. I'm going to go to the 24-hour 1-inch rain. It came in. And we're going to look where the big precipit's going to be. And clearly, it initially lights up in California and Oregon. And then a big storm comes in, it lights up in California. And then notice that one wave comes, the first wave gets out into the plains, it lights up right where the CFS has that dry area, and I actually can see there's a 2-inch contour down there. So the GEFS, the newest GEFS, like the previous run, is optimistic that's actually going to be wet in probably in the western edge of the Ohio Valley, and it looks like at least 2 big rain events on the West Coast. So let's look at something new and different that you've probably never seen before. I'm going to say that 80% of the people in the room have never seen this before. So we're going to look at the 24-hour GEFS forecast of the QPF as a ratio of the 100-year 24-hour return rainfall, annual return, average return interval, recurrence interval. So we'll go to the beginning of this. So you can see that the upper panel shows if any members have 75% or more. It's a probabilistic forecast. The upper panel shows the mean QPF and the GEFS versus the ratio of the 100-year 24-hour ARI. And you can see it actually throws a signal in California. It looks like the scale's at the bottom. Let me slide down. And there's no scale. I wrote the software. I'll talk to the guy who didn't do that. But anyway, it's about the yellows are 75%. So it looks like, and then it really lights up in Oregon, about 75% of the 100-year return interval, and it doesn't pop any 75s. So, but it looks like there's a pretty good chance of a significant rain event. Looking at this guidance in the Pacific Northwest, mainly Oregon. Oregon's going to have a close to 100-year 24-hour rainfall event in the Sunday-Monday time frame. Now, the rain that comes through the Gulf states looks like we're probably going to hear about some minor flooding, maybe, if this is true. There's actually some reds in there. They're hard to see. The second color of yellow is actually in the contour. So it's throwing the potential for close to 100% of a 100-year 24-hour rainfall event in the lower Mississippi Valley. So that's kind of interesting. So, and then it goes away, and you can see it's pretty boring for us. We get to about the 20 to 25% chance at the end of the forecast period. So let's zoom in on the west. Oh, we'll do the south. Doesn't matter. I have something to do when I get back to it. So yeah, the yellows are 75 to 100%. So looks like a pretty interesting rain event in the southern Mississippi Valley potentially this coming weekend, I guess. And if we go to the western United States, because there's nothing really interesting going on here, I don't think, unless I'm missing something. And you can see we got some yellows in California to start the game, and then it goes away, and then we get some yellows. So we're approaching 100%. So it's probably going to be another big rain event. I think this thing actually lit up like a tree a couple days ago for the Seattle area. We actually got the lower panel light up. So, but it's pretty interesting, I think. It's just kind of a fun thing to look at to see is the model forecasting a record rain event. So anyway, let's go to the SREF, and we'll see what here's the SREF in the western United States, and you can see it too is catching on to the fact that there'll be a major rain event. This one has in Oregon also, and it actually is, the SREF is actually popping about. This one has a scale on it. 20 to 30% of the members are showing about that. Are popping more than 75% of the 100-year return rate. It's really weird. I'm getting a percent of a number that's a percent, so it's kind of confusing. But it's just an interesting concept. It's not as good as M-Climate, but we don't have M-Climate for the SREF, so it's a way to look at the data. I literally just made this up like about a week ago, 2 weeks ago, so they're pretty new to me. I've done them for the HER and the GFS and the NAMS back in April, but trying to display it in the ensembles was kind of a fun thing to do, I think. So anyway, we have the data set for the whole United States, and I guess we have some areas we have 1, 2, and 12. It looked really good for the South Carolina floods that I showed in Kyle's class. So, but the weather here, nothing to write home about. We talked about this already. Unless I'm missing something, maybe we have another little bit of fog maybe in the morning tomorrow. But it looks like we're going to have a prolonged period where we potentially can stay at or above freezing. Our 850 temperatures are going to stay well above freezing for quite a period of time, and there's no real cold episodes in store for us. And if I switch in focus off this page, I think I can go to the. Why can't I expand this browser? Like it's a dead wall there. I can't go beyond here with the mouse. Is that? Oh, there we go. Learn something new every day here. Sorry for my kludginess. Oh, that's supposed to be an S. I wanted to see if the new CFS came in.
Records are mid-60s.
Mid-60s.
Oh, good.
There we go. So there's a link to those plumes. Will they load? I had trouble loading them in Kyle's class this morning. But this is the GUI that has the tuning temperatures, and for some reason, it loads at my office, doesn't load here. I wonder if the weather service has this blocked out right now. I can do this in my office. I can't do it here. It's kind of tragic.
I've done it in my office.
You have?
Yes.
I'll try 0Z. Well, it doesn't load on this computer. Something's blocking it. It's a pop-up. I wanted to see. I showed you the forecast earlier because I wanted to see if it has any snow. So apparently it's not loading here. I apologize. So anyway, we'll just go back. We'll look at the precip potential here for us. It looks like we have a shot at rain at the end early next week. Maybe a modest, half-inch rainfall event. There's about I've noticed that if you multiply the GFS mean QPF by 7.7, you get a better wag of what might really happen. And then on the 18th, a couple of the members at least say we could have snow, but there's a minimum of 0, so I think we're going to go to the 18th at least probably with it's a sure bet. If I'm not going to have any measurable snow here till at least the 18th or 19th of the month. So anyway, I'll just go back to the PowerPoint. So basically, I want to thank everybody for being here today. We had a pretty good, interesting semester. We had some interesting storms early, like back in October. The South Carolina event was kind of fun, and it's been warm. We had no winter weather to speak of to talk about here this autumn, which is kind of rare. And everybody's still excited about El Nino, except apparently El Nino. And we have these new CFS tools we can look at, and the CFS keeps us warm into the coming new year. And I think our recent fog event is probably interesting and probably deserves further study. It was kind of fun to live through it, and it was pretty cool to see how icy it made the roads Monday morning, and the ice needles that apparently snowed by the mall and the sewage plant. And then our final weather says I don't, other than the 6C GFS, I don't see any reason for Bing to sing. So, and I personally won't because I don't want to clear the room. So thanks. Yes.
You mentioned the snow event up by the mall.
Yes.
Have you ever seen that happen before? Is that the first time?
Personally,
Due to that sewage treatment.
I've seen that phenomenon before. And I talked to Aaron Taberski. Actually, was there. He took the video and took the pictures, and the way he described it was like it was more like ice needles and stuff. So I guess in the Washington Post article relating it to lake effect snow was ridiculous because it was absolutely stable. And so it's just, my guess is they had, here's my theory. I had to drive to Evansburg Sunday afternoon. And when I was driving to Evansburg, I crossed Skytop, the temperature rose about 8 degrees. And whenever I was on the ridges, it was like close to 50 degrees on the way to Evansburg on Sunday. And whenever I got in the valley locations on 99, it was in the 30s. When I got to Evansburg and gave my grandkids back to my daughter and came back, it was when I first got to Evansburg, it was 49. When we left, it was 46. We weren't there very long. But on the way, when we're in the valley, you could see anybody who was burning coal or wood, their smokestack, their smoke was going up about 200-300 feet, and it was flattening out. And you could see certain valleys, people burned a lot of wood stuff, and they were polluted. You could see that. So we had a lot of anthropogenic. My theory is a lot of anthropogenic nuclei trapped in the boundary layer, and the boundary wasn't very deep. So when we came off the mountain at Evansburg, we got to Altoona, it was 35, and the temperatures when you got up. On 99, you go a little higher, got to about 39, 40, and every time it went lower, it went down to 30s. By the time I got to Park Forest, it was 32 degrees. And on the way back, it was getting dark, so you couldn't see as much, but you could see there were fumigated valleys due to anthropogenic sources. So my guess is that night we radiated, and we had a lot of anthropogenic nuclei got trapped in the boundary layer, and probably where the population was dense, you had more of it because it didn't go very far. By the way, any house that looked like it was burning like gas or oil didn't have a plume coming out of it, you can notice. But anybody, and I knew it was wood stoves immediately because some of them had those giveaway houses in the back where they burned the wood and then they pumped the water into houses. And every one of those was like just pollutant like you wouldn't believe. So my guess is the only contribution the sewage plant probably had was a little extra water vapor, but not much based on the guy who works there. But I think we had it was probably denser fog there, and maybe you had some ice nuclei. And so, because Aaron actually said he saw it was more ice needles. It actually snowed at the office outside my window. But that was different. That was we had all the frost and rime buildup, and then when it started to mix a little bit, it all fell off the building, and it had ice crystals fall off the building. But that was easy to to figure out why. But I guess we just ice nucleation would be my theory. It clearly wasn't cedar feeder because the soundings. John Neese sent me a beautiful sounding I kind of demonstrated. It was just shallow moisture and it was completely dry above, so it wasn't traditional snow. And Aaron's description implies maybe it was ice needles, but I don't think the sewage treatment plant did anything more than just maybe increase the relative humidity a tad. So maybe it's just it was colder there because that fog was really dense in the lower spots that day. It wasn't so bad in Park Forest, and I came over past the Armory. It just was everything looked like it snowed, and it just was the rhyming was unbelievable. But apparently there they had some ice needles. Aaron captured it on film. Well, on his camera. Anybody else? That's my best. I don't know. Anybody have a better prevailing theory? I'm open to suggestions. Anybody else?
I have another question. So for the fog, given that the models handled that so poorly, what subjective forecasting rules can you use to say whether the fog will burn off or not, what time?
That's a difficult question. I want to say that if you looked at the HER, each successive run of the HER tried to hold on to it longer, but the NCEP HER couldn't keep it beyond about 2 hours. The GSD HER actually did a lot better, but it still wasn't good enough. Like how deep the fog is probably important, and we began to look at some of the GOES low cloud thickness products and stuff like that. Some just experimentally, just try to figure out. I think that we, and myself included, we're really like we're on the oar in a model ship, rowing the oar, and I think the expertise that we used to have because the models were so poor is dying, and it's probably one of the few cases that we could learn from. We probably could improve upon it if it ever happened again. But most of us are just rowing the ensemble and model oar, and I don't know how much we could have done better. I asked people specifically that. 3 people in my office specifically, and that we're kind of slaves to the performance of the models maybe, and I don't know if good forecast skills could have helped out. I think that was a rare event here. Like you've been here with John, Billy, and Paul 30 years. Yeah. And how long have you ever seen that? Like, yeah. So it was probably a very rare event. And
hey, Rich, there's a COMET module that was commissioned by the Air Force. Specifically related to fog and forecasting fog, and there was actually some case studies, so it's online. I went through it last summer, not this past summer.
Did it help you?
Well, I was thinking about it with this case because it actually gave some very good tools that are not just model related.
It's a great case. It's interesting. Had a lot of very local phenomena. It was interesting. Like on Saturday, I cleared up at my house much earlier than the people on this side of town. So I got to like 43 degrees on Saturday. But Sunday, I thought I cleared out really early relative to some people, but there were people who cleared out, like Lamont cleared out before Park Forest apparently, but in town it was really cloudy until at least 1 o'clock. So I only got I only got to about 40-ish at my house. And then on Monday, it must have never cleared up my house because I stayed in the low 30s on Tuesday. It was really cold. Like John LaCourte and I, we have Davis weather stations, and we flip-flopped who was in the 40s on different days. It was kind of funny, like how it varied. I think I got to 40, maybe I got to 47 one of those. Monday I must have gotten to 47 brief. I wasn't there to observe it. I didn't enjoy it. I was there to look at the trace afterwards. But it was funny how different parts around town, like everybody had different high temperatures, and they were like 6-7 degrees apart in different days. Very, very localized phenomenon. Difficult, I think. Beyond the skill of our models right now, I believe. Unless they have really good data and physics in the boundary layer, right? So, anybody else?
We have a Twitter question.
Uh-oh, a Twitter question.
Question for Rich. Do you see any signs of a pattern change away from the El Nino heading into the late month/January?
Well, I looked at the we can go back. We'll use the CFS as a way. The CFS says that the El Nino, of course, and the CFS is going the El Nino is supposed to be weakening over time as we go into the new year and to the spring. But the CFS kind of says we are at least going to trend locally more towards normal. But it looks like if I'm reading those numbers right, we're probably on the slightly warm side most of the time of normal, with the exception. This is the run from last night, but mind you, with the exception of the period from about the 28th to the 2nd of January. where we might actually be normal to below normal. So the CFS is saying the overall long-term trend is we're going to probably be normal to above normal most of the time. And I'll use the CFS instead of other tools.
The CFS monthly anomaly for January has consistently, every day's run has been a high probability of a warmer than average January.
Yes.
75% probability
Yes.
of a warmer than average January.
The only saving grace is it had the same kind of thing last year. It did. But, yeah. I don't see any big pattern changes, though, coming up. Is anybody?
Stratospheric warming.
Is anybody looking at 10 hectopascals? What?
I have, but there's nothing.
Nothing going on. Anybody else?
63 Sunday.
63. That's the record? We have a shot.
Oh, I think so. Yeah.
We have a shot. Well, thanks.
Thank you.
We will not have a weather briefing the very first week of next semester due to a large number of the students and faculty being at AMS. So we'll start the weather briefing the second week of spring semester with light temperature.
Thanks.
Nice.
Thanks.